Virtual Earthquake is an interactive website that's been available on the web for many years. It allows students to mimic the process of determining the origin or location of the epicenter of the earthquake and its magnitude on the Richter scale. And it does this very simply. It's a wonderful example or a wonderful introduction to the science of waves. So here we have the website and we can execute the virtual earthquake activity. So this gives us lots of information. You can stop this video at any time to view the information, and it describes the simple form of a seismogram. So let's select an earthquake. We've got the San Francisco one here, and it explains how to measure the SP interval, the time interval between the primary waves and the secondary waves. So we've got to measure the time between the initial primary wave and the initial secondary wave. So that looks to me like it's 49 seconds. And this is from a different site, and that looks to me like it's 72 seconds. And the third seismogram, the third location, gives a time interval of 64 seconds. So let's convert the SP intervals. This shows how we can set up a sliding scale for the time and the distance. So 49 seconds corresponds to a distance of 480 kilometers. 480, and 72 seconds corresponds to a distance of 695, approximately 695 kilometers, and 64 gives a distance of 605. So let's find the epicenter. And it looks quite close. They all meet at the single point here. So we'll view the true epicenter and let's see how we did. Oh, we got very, very close. In fact, we're spot on in this case. So this explains how simply from 3 seismographs obtained at 3 different locations and an understanding and knowledge of the S and P wave travel speeds, we can identify the position of the epicenter. But that's not all. We can now compute the magnitude. Again, if you wish, you can stop this video and read the material. What we have to do is look at the distance and the amplitude. So the S wave amplitude here is 260, say 280, and this one is only 60, and this one is 100. So we submit to the nomogram and we find that they meet. The lines are joined between the distance scale here and the amplitude there. So if we are far away and a big amplitude, then that will give us a big value on the magnitude. But if we are up close and we only have a small amplitude, then that will give us a small magnitude. So in our case, our magnitude is about 7.1. Reading off the graph there, confirm the magnitude, and now we can have a certificate sent to us. I'll forgo that privilege.